All right, let's just do a couple of more problems on the population variance, finding the confidence interval. Okay, so again, remember our equation is n minus 1 degrees of freedom, standard deviation of the sample squared over our chi-square value for the lower limit, and that's going to be our variance, is in between the same thing on the top over our chi-square for the upper limit. Okay, so again, all we have to do is just plug in what we're given. We know that, let's see what they say here. Looks like our n value is 14, our sample deviation is 3.12, and we want a 98% confidence interval. So let's just start plugging this in. Okay, so first things first, change colors. We have 14, so n is 14, so 14 minus 1, that's going to be 13, right, times whatever that is. But let's take a moment and let's figure this out. They told us the standard deviation of the sample is 3.12, but what we need is that squared. So really what we're looking for is we need to do the sample standard deviation squared, which, again, use your calculator for this. I pulled this up. It should be something like 9.73. Okay? So we can plug that in. 9.73, and then, hold on a second, let's just fill this all in. So our population variance is going to be somewhere in between this and same thing on the top, 9.73. Whoops. Oh gosh, that just looks so atrocious. I'm sorry, I think I'm a little distracted because I'm making a pot of chicken stock and it is smelling so good. Oh, the house is just, Anyway, okay. Sorry, try to stay on statistics focus here. Okay, so anyway, so they didn't directly tell us what the S squared value was. They just gave us standard deviation, but it's not too hard to just take that, square it, and then plug that in. Okay? So we got that. So now the final bit that we have to do is just figure out what is going to be our 98% confidence interval. Well, again, remember, we split the difference between, we're allowed a 2% error rate, so that means we have 1% on the upper end, 1% on the lower end, which means that we should have our chi-square lower value should correspond to 0.01, and our chi-square upper value should correspond to 0.99. Okay, because that gives us 1% error over here, 1% error over there, which is half of what we are allowed to do. So then all we have to do is just look this up on a table. Okay, oh, actually, I forgot. What is our n? Our n is 14. So that means we need to have the degrees of freedom. N minus 1 is 13. So, oh, it's right here. It's highlighted. Look at that. So then we need a 0.99, which is going to be 4.11. And then the upper value, or the lower value, is going to be the 27.69. So let's just plug those things in. So the upper value is 4.11, and then it was the other one was, what was this again? It was 27.69? Something like that. Okay, and then calculator work. Whip out your calculator, figure this out. Somewhere in between, it's going to be what? 4.57, and then the other upper value is going to be 30.78. Okay, so that is our confidence interval for the population variance. That's this part right here. Okay, so then the last bit is population standard deviation. All you have to do is, once you've figured out the population variance interval, just take the square root. Right? So it's just going to be, take square root of that, take square root of this, and that's going to be, check your calculators, but it should be something like 2.14 on the lower end and 5.55 on the upper end. And that would be our answer. Okay? These would be the ranges. So, one more problem, and that will be it. Let's do this one. Part of a water quality survey, test water hardness, several. It's always something boring, isn't it? Right? It's never something that is, who really cares? But, anyway, sorry. For all you water hardness experts out there, I apologize for slamming your field. But, okay. But anyway, so the same thing, right? We know S is this, N is that, and it's a 90% confidence interval. So again, what's the equation? I know at the risk of redundancy, here it is. S squared over our chi-square lower limit, and that's going to be our very confidence thing is going to be in between that, and whoops, what am I doing? Oh, brother. Oh, man. Okay, here we go. S squared, chi thing, upper limit. Okay, so let's plug in what we know. Well, we know N is 21, so that's going to be 20. Now, S. They didn't tell us S squared, but they did tell us S. So all we got to do is just square that. And 12 squared is equal to 144. So let's just plug these things in. Okay, so N minus 1, it's going to be 21. Minus 1, it's just 20. Times 144. Oops. Actually, it's not less than or equal to. Excuse me. I'm distracted by the chicken broth. Okay, and then 20 times 144. All right. And okay, now, the tricky bit. What goes on the bottom with our 90% confidence interval? Okay, so again, remember, oops, let's do that. You know what? Let's go do pink. I feel like pink. I'm in a pink mood. So if our data is spread like so, 90% means we're allowed 5% error on either end. Okay, so we can be up to 5% wrong here and up to 5% wrong there. Okay, because that would mean that the inside bit here, the part where we're confident about, in blue, that would be 90%. Okay, so then all we have to do is just figure out, okay, what would that allow us? Well, that means if we're allowed up to 5% on the zero end, that means we're at 0.05 on the lower end. And if we're allowed 5% error on the upper end, remember, it's up to 100%, so we're allowed to have 95% error on the upper end. So all we have to do is just simply use our table with these values, and our N is 21, so then the degrees of freedom are just going to be that minus 1, so that would be equal to 20. Okay? So here, let's look at it. So if our degrees of freedom are 20, here they are. Oh, let me use the mouse a second. It's not working with this little stylus pen. There we go. Okay, so here's our column that we're interested in. Degrees of freedom are 20, and we want something that's at 95 for our upper bound, so that's 10.85. And then for the lower bound, we're allowed 5% error there, so that's 31.41. See how it matches up with these things? So all we gotta do is just plug those numbers in. Alright, and if I hadn't written them down, I would have completely forgotten them, because that's just how dumb I am. Sad, but nevertheless true. Okay, so it's, what was it, 30.14 for the lower end, and on the upper end it was 10.12, and, you know, there we go. You just figure out what that is. That would be somewhere in between 95.55 on the lower end, and on the upper end it's, whoa, 284.58. Big numbers, but whatever. Process is what matters. Okay, so there we go. We figured out the population variance, or the confidence interval for it. Last thing is, they said they wanted the population standard deviation, so again, that's just the square root of all of this. So that would be, take the square root of 284.58, and you end up with something like 16.87, and then if you take the square root of that, it's 9.77. And there you have it. Hopefully this was informative. If not, again, as I always say, leave me some scathing comments, or at the very least, maybe just point out some areas where you're not following what I've been doing, and I'd be more than happy to make videos addressing those points. But if not, Godspeed, Horatius.